Hello, welcome back to my channel. In today's video, we will discuss a few question about data science. Let's get started. First question: how is unstructured data analyzed in the context of data science? In data science, unstructured data refers to information that does not have a predefined structure or schema, such as text, images, audio, video, and social media data. Unlike structured data, which fits neatly into tables with rows and columns, unstructured data can be messy and difficult to analyze directly. Here's how unstructured data is typically analyzed. First, data collection. Source. Unstructured data can come from various sources like images, social media posts, PDFs, videos, IoT devices, or logs from software systems. Tools, tools like web scrapers, APIs, or other specialized platforms are used to collect these data. Data preprocessing. Cleaning. Since unstructured data is often noisy, contains errors, incomplete parts, or irrelevant information, cleaning is essential. For example, text data may require the removal of punctuation, stop words, common words like the and special characters. Transformation. These involves converting the unstructured data into a format that can be analyzed. Text data. Some examples include text data tokenization, breaking text into individual words, stemming or lemmatization, reducing words to their base forms, and converting text into vectors using techniques like TF-IDF or word embeddings. Image data. Images might be transformed into pixel metrics and various image processing techniques. Example, age detection filters might be applied. Audio video. For audio techniques like speech to text or spectrograph analysis are often used. Feature extraction. Text. Feature extraction for text data can involve natural language processing techniques such as bag of words, counting word occurrences, TF-IDF, weighing words based on their importance in a document, word embeddings, using models like word to back or GLOVE to capture the context and meaning of words. Image video features are extracted using computer vision techniques. For instance, convolutional neural networks CNNs can be used to detect patterns in image data. Audio features like frequency, pitch, and duration might be extracted. Data storage. No SQL databases. Unstructured data is often stored in databases like MongoDB or Elasticsearch that are designed for flexibility and scalability in handling diverse data types. Data lakes. A data lake is a storage system that can hold vast amount of raw, unstructured data in its original form. Analysis method. Text data. For text data, text mining. Extracting meaningful patterns from text such as sentiment analysis, topic, modeling, or keyword extraction. NLP. Techniques like named entity recognition, part of speech tagging, and machine translation. Image data. Image recognition, detecting objects or patterns in images using deep learning models like CNN. Facial recognition, identifying and verifying human faces using algorithms. Audio video, speech recognition, converting audio to text, action detection, identifying actions or objects in video clips. Machine learning and predictive modeling. After feature extraction, machine learning algorithms are applied to unstructured data to create models. Common tasks include classification, categorization data, spam detection, sentiment analysis, clustering, grouping similar data points together. For example, customer segmentation regression, predicting continuous outcomes based on input features. Visualization, text, word clouds, frequency histograms, and topic graphs, images, image overlays, feature maps, audio, spectrogram, spectrograms, or waveform graphs. There are some challenges to analyze unstructured data. First, volume. Unstructured data is often vast and grows rapidly. Variety. It comes in many forms, text, images, video, etc., requiring different pre-processing techniques. Complexity. Extracting meaningful features from unstructured data often require advanced algorithms and domain-specific knowledge. By processing and analyzing unstructured data effectively, data scientists can uncover insights that are often hidden in traditional structured data alone. Example. An example of data mining activity used to analyze unstructured text data is sentiment analysis. Sentiment analysis is a technique used to determine the emotional tone behind a body of text, which helps to understand the sentiment, positive, negative, or neutral, expressed by the writer. Example, sentiment analysis of product reviews. Imagine a company wants to analyze customer feedback from thousands of unstructured product reviews to understand how customers feel about their product. Step by step process. First, data collection. The company collects product reviews from multiple sources such as e-commerce websites, social media, or customer feedback forms. The collected data is an unstructured form, typically as raw text. Text pre-processing, tokenization. Break down the text into individual words or phrases, tokens. Stop word removals, eliminating common words like the, is, that do not carry significant meaning. Lower casing, converting all text to lowercase to avoid case sensitivity. Stemming or lemmatization, reducing words to their root forms. Running becomes run. Feature extraction, bag of words, representing text as a set of words and their frequencies. TF-IDF, term frequency, inverse document frequency, weighing the terms based on how frequently they appear in the text relative to how often they appear across all reviews. Word embeddings, using models like Word2Vec or GloVec capture the semantic meaning of words in a vector space. Sentiment classification. A machine learning model, for example, logistic regression, name based, or deep learning models like recurrent neural networks or BRT, is trained to classify the reviews as positive, negative, or neutral. The training data might include a labeled data set of product reviews where each review is tagged with the corresponding sentiment. Fifth, analysis. Once the model is trained, it can predict the sentiment of new unseen reviews. The company can analyze patterns like overall sentiment, what percentage stage of reviews are positive, negative, or neutral. Product insights. Identify the most frequent issues in negative reviews or the most praised features in positive reviews. Trends over time. How does sentiment change over time, especially after product updates or new releases? Visualization. The result can be visualized using graphs like pie charts or bar graphs to show sentiment distribution, word clouds to show frequently mentioned words in positive or negative reviews, sentiment over time graphs to see how sentiment fluctuates across a timeline. Example output. Positive review, the product works great. I love the design and functionality. Sentiment positive. Negative review, the product stopped working after 2 weeks. Very disappointed. Sentiment negative. Neutral network. The product is okay. It gets the job done, but nothing special. Sentiment neutral. The data mining activity allows the company to gain actionable insights from unstructured text data, improving product quality, customer experience, and overall decision making. Now we discuss case study, a complaint such as theft of my mobile phone by an unknown person at MG Road on 20 Feb 2023. The phone was stolen while shopping in a store. The thief was wearing a black jacket and had a scare on his face. Now, let's discuss the solution of case study. The approach to identifying the appropriate IPC or VNS sections involved several steps. First, text pre-processing. First we pre-process the text by removing unnecessary words and extracting relevant keywords like theft, mobile phone, MG road, and date. Then, using named entity recognition, identify entities such as locations and date. Then, text classification. Using a trained machine learning model, classify the complaint into a category such as theft. The IPC section 378 theft might be applicable. Algorithm selection. Algorithms such as decision trees, support vector machines, SVM, or name base can be applied to predict the legal sections based on the text. Based on the complaint, IPC Section 378 theft is likely applicable as it relates to the unlawful taking of another person's property. Data structure and algorithm for legal classification. The task of classifying a complaint into IPC or BNS sections requires suitable data structures and algorithms to process and classify the text data. Data structure, text representation. The text can be represented using data structures like term frequency, inverse document frequency, TF-IDF, vectors, or word embeddings. These structures convert raw text into numerical vectors that machine learning algorithm can process. Feature matrix. A matrix where each row represents a complaint and each column represents a feature is commonly used as input to machine learning algorithms. Algorithm, text classification algorithms. Supervised learning algorithms such as name-based, support vector machine, and logistic regression can be used for classifying complaints into relative categories. Natural language processing, NLP techniques, algorithms for tokenization, part of speech tagging, and named entity recognition help in extracting important features like the crime type, example theft, and other entities, example location and date. These algorithms will help categorize the complaint under an appropriate IPC or BNS section by analyzing its content. Performance metrics for text mining, which is used in case study. The performance of algorithms in text mining can be assessed by using several key metrics. First, accuracy, precision, recall, F1 score, confusion metric. Accuracy measures the overall correctness of the classified by calculating the percentage of correctly classified instance. Accuracy equals to total positive plus true negative upon total samples. Precision, the proportion of true positive results among all positive predictions, indicating the reliability of the classifier. Recall. The proportion of true positive results among all actual positives, showing how well the model captures relevant data. Advanced score, the harmonic mean of precision and recall used when you need to balance both metrics. F1 score equals to 2 into precision into recall upon precision plus recall. Confusion matrix. A table used to evaluate the performance of classification model by displaying true positives, false positives, true negatives, and false positives. These metrics allows for the evaluation of how well the text mining model classifies complaint into the correct IPC or VNS section, ensuring the model's effectiveness and accuracy. These standard answer. Thank you for watching.